The Antonio Project presents Inner Gas System Part 1, The Noble Gas. Hello everyone, good day and welcome back to my channel. At this time, we are diving into the mysterious and intriguing world of inner gases, those quiet noble elements that play crucial role in our universe. From neon light to the air that we breathe, these gases are everywhere, yet often go unnoticed. Inner gas system play a crucial role in preventing explosion and fires while transporting volatile cargo. But what exactly is inner gas? We will discuss from the basic understanding of inner gas to the application in the daily life to the use of for transporting flammable cargo. And this is part 1 about noble gas. Before we dive in, please note that the information presented in this video is intended for educational and informational purposes only. While we aim to provide accurate and engaging content, this video is not intended to be comprehensive or definitive on the topic of inner gases and its properties. Stick around as we uncover the unique properties, fascinating uses, and surprising facts about these elements that are anything but ordinary. Let's get started. Periodic table of the elements. Before discussing about inner gases, let's take a look to the following periodical table of elements. The periodic table of elements is a systematic arrangement of 118 known chemical elements. These chemical elements are organized in order of increasing atomic number. Periodic table families is a family consists of elements having similar characteristics. The elements of family may belong to the same group or spread across several groups. Each family of elements is color-coded to understand their position in the periodic table. These families are typically organized into vertical column or groups on the periodic table. Following is major families in the periodic table. 1. Other metals have some characteristic of transition metals but are soft and conduct more poorly than transition metals. 2. Transition metals lie from group 3 to group 12. They have more than one oxidation state, meaning they can have many oxidation numbers. 3. Metalloid. They display properties of both metal and non-metals. For example, metals are good conductors and non-metal are poor conductor. Their melting points are lower than transition metals. 4. Non-metals. They span in groups 13 and 16. They have high electronegativity and ionization energy and are poor conductors of heat and electricity. 5. Alkaline earth metals are located in group 2 of periodic table. They have 2 electrons in their outermost shell and are the second most reactive after alkali metals. 6. Alkali metals are all elements of group 1 except hydrogen. These elements have 1 valence electron. They are highly reactive and can burst into flames when exposed to air. 7. The halogen lie in group 17. They are highly electronegative and reactive, requiring 1 electron to complete their outermost shell. 8. Noble gas. They have complete outermost shells resulting in stable electron configuration. 9. Lanthanides are part of the 6th row and lie within group 3 of the periodic table. They are a family of rare earth metals with 1 valence electron in the 5d shell. 10. Actinides are located in the 7th row and within group 3. They are another family of rare earth metals that are highly reactive. The vertical columns of periodic table are called groups. There are 18 groups. The elements in each group have the same number of valence electrons and hence have similar chemical properties determined by the outermost electrons. The horizontal rows from left to right in a periodic table are called periods. There are a total of 7 periods in the periodic table. The elements are arranged horizontally due to their similarities in properties, like the same atomic orbitals, same number of electron shells or energy levels, and so on. Atomic number, or C, is the number of protons that constitutes an element's nucleus. For example, nitrogen contains 7 protons, so its atomic number must be 7 only. A symbol is a notion that is used to represent a chemical element using a letter or a combination of 2 to 3 letters. For example, the chemical symbol of nitrogen is N, while Cl is used for chlorine, and so on. This table breaks up the elements by their state of matter: synthetic, liquid, solid, and gas. The name lanthanides come from the first element of that row, lanthanum. Actinide's name comes from actinium, the first element of that row. Introduction to what is noble gas. Noble gas refers to a group of elements characterized by their low reactivity and stable electron configuration. These gases are located in group 18 of periodic table and possess a full outer electron shell, making them highly stable and unlikely to engage in chemical reaction with other elements. Due to their inertness, they are often used in various practical applications. Following are the properties of noble gases. 1. Non-reactive. They do not combine easily with other elements. 2. Colorless and odorless. In their natural state, noble gases are colorless and odorless. 3. Low boiling and melting points. These gases have weak intermolecular forces, resulting in low boiling and melting points. 4. Monatomic. They exist as a single atoms, not as molecules. For example, helium, neon, and so on. All noble gases have a completely filled valence electron shell, which make them chemically stable. In chemistry and physics, valence electrons are electrons in the outermost shell of an atom, and that can participate in the formation of chemical bond if the outermost shell is not closed. Noble gases are mostly unreactive due to their stable octet or duplet for helium at their valence shell. The following animation showing the electron configuration of noble gases. The electron configuration of an atom is the representation of the arrangement of electrons distributed among the orbital shells and subshells. Commonly, the electron configuration is used to describe the orbital of an atom in its ground state, but it can also be used to represent an atom that has ionized into a cation or anion by compensating with the loss of or gain of electrons in their subsequent orbitals. The noble gases include helium with element or atomic number 2 and duplet or 2 electrons in their valence shell, neon with atomic number 10, argon with atomic number 18, krypton with atomic number 36, xenon with atomic number 54, radon with atomic number 86, and last is oganesson with atomic number is 118. These four last noble gases having 8 electrons or octet structure in their valence shell. The use of noble gases. Noble gases find use in fields such as lighting, welding, cryogenics, and as a protective gas in industry to prevent unwanted chemical reaction. Following is the sample of noble gas application in industry or daily life. Uses for helium. Balloons. Helium's low density is used to fill airships and decorative balloons. It is lighter than air, hence it floats in the air. Deep sea diving. Deep sea divers carry cylinders that contain a mixture of oxygen and helium. Uses for neon. Advertising signs. When electricity is passes through the neon gas in a vacuum discharge tube, it glows with reddish-orange color. Lasers. Neon is combined with helium to create lasers. Argon is the most abundant gas among all noble gases found in the atmosphere, making up of the air we breathe. Welding. Argon is often used in arc welding to provide an inert protective shield around the hot metal when welding. Like bulbs, argon is key component in both incandescent and fluorescent light bulbs. Uses for krypton. Photographic flashes. Krypton and argon are both popular for creating photo flashes for high-speed photography. Krypton is used commercially to fill energy-saving fluorescent light. Uses for xenon. Strobe lights. Xenon doesn't glow when passes through a vacuum discharge tube. Instead, it flashes a brilliant white light, making it perfect for creating strobe lights. Sterilization. Xenon lamps generate light on such a frequency capable of destroying bacteria on surfaces and in the air. Radon is a radioactive noble gas and can create a risk if it seeps into houses. Some of its uses are cancer therapy. Radon's inherent radioactive nature finds wide application in cancer therapy. Radon glass tubes are implanted directly into the tumors as a kind of targeted radiation therapy. Oganesson is radioactive synthetic element which does not occur naturally on Earth. It is likely that oganesson is a gas at room temperature. Since only a few atoms of oganesson have ever been produced, it currently has no uses outside of basic scientific research. Are all noble gases is inert gas? The full valence electron shells of these atoms make noble gases extremely stable and unlikely to form chemical bonds because they have achieved a stable electronic configuration, which means they do not need to gain, lose, or share electrons to become stable. Although noble gases do not normally react with other elements to form compounds, under certain extreme conditions, some noble gases can form compounds with other elements. Following are several compounds formed by noble gases with other elements bonding. Helium forming helium hydrates, argon forming argon fluorohydrates, krypton forming krypton difluoride, xenon forming xenon oxide, xenon difluoride, xenon tetrafluoride, xenon hexafluoride, and radon forming radon difluoride. An inert gas is a gas that does not readily undergo chemical reaction with other chemical substances and therefore does not readily form chemical compounds. by Wikipedia. The noble gases, or historically the inner gases, sometimes referred to as aerogens, are the members of group 18 of the periodic table by Wikipedia. Inner gas is a non-reactive gas under particular conditions by IUPAC World Book. Historically, all noble gases are inert under normal conditions. The term inner gas is contact dependent because several of the noble gases can be made to react under certain conditions. Inert gases and noble gases are often used interchangeably, but they are not exactly the same. While both terms refer to elements that are generally unreactive, there are some subtle differences between the two. I think that's all my video about inner gas system part 1. Noble gas. In order to get full understanding about this topic, what's next part? Part 2, video about nitrogen. See you in my another video. Bye-bye. I hope that you enjoy my video. And if you think that my video is useful, be sure to click the subscribe button to my channel. That is the best way to support what I do to share knowledge. Your support means the world to me, and I truly appreciate you taking the time to join me in this journey.
Thank you for watching my video. Terima kasih. Di Antonio Project.